Hey guys, so I'm going to go through this problem with you. We're solving for x in the specified domains, and we have to make sure to check for extraneous solutions. So today we're looking at two radicals versus one, so it's the same steps. We want to isolate just one of the radicals to start. In this case, we do have an isolated radical on the right, and the one on the left technically is also isolated because the 4 is being multiplied. So when we square it, to get rid of this radical on the right, it's okay to have that coefficient out here as long as it's being multiplied, because when you square, you can distribute that exponent. So technically, the left and right are both isolated right now. So when we do that, we get 4 squared times x minus 1, because the squared cancels that root sign, equals x plus 2. And now I'm going to go through and solve. So 4 squared is 16, and I will need to distribute that 16 through, and when I do that, I get 16x minus 16 equals x plus 2. I will go ahead and move the x over, and the 16 over. So this will cancel, and I have 15x equals 18. When I divide by 15, I will get x equals, and I need to decide if I can reduce this. If I reduce by 3, I'm going to get 6 over 5. Now I'm going to need to go through and check to make sure that this is not an extraneous solution. So if I'm going to go through and check to make sure that this solution works, I'm going to go ahead and use my graphing calculator and show you a little trick here. So if you go to your graphing calculator, you can store 6/5. So how you do that is hit alpha y equals to get your fraction notation. And I'm going to do 6 over 5. And above the on button, there's this arrow. So first arrow out of the fraction. See the STO, S-T-O with an arrow? If you hit that, and then I hit x, which is next to alpha, that stores the value after you hit enter in the x. So that means now I can plug in my calculator just the left side of the equation. So 4 times the square root of, and I can just plug x because I stored x to equal 6/5. So if I plug in the x minus 1, and hit enter, then I can plug in the other side, second square root of x plus 2, and you'll see that that gives me the exact same value. So therefore that tells me that 6/5 works. So showing my check, I'm plugging in 6/5 minus 1. Is it equivalent to 6/5 plus 2 under the root here? And it does work. So I do not have extraneous solutions in this one. For my solution set in the reals, I would have 6/5. And if I had whole numbers, I would have empty set because 6/5 does not fit in whole numbers. Okay, moving on to the next example with two radicals. So you'll notice this one is when you have radicals isolated on one side already, and then by squaring it cancels them. This one's a little different. So we need to isolate one of these radicals, so I'm just going to move one of them. So I'm going to move this over. And I have the square root of 3x minus 2 equals 5 minus the square root of 4x plus 1. Now I'm going to go through that process to cancel the square root by squaring both sides. On the left here, I'm going to move over for space. I have 3x minus 2 equals, now this means I have two of these, 5 minus the square root of 4x plus 1. And 5 minus the square root of 4x plus 1. So I'm going to have to FOIL with radicals, which is not the end of the world, just a little bit uglier. So I'm going to distribute, so I have 5 times 5. Well, first I'll leave the left side alone. 5 times 5 is 25. Then I'm going to take 5 times this root 4x plus 1, so minus 5 square root 4x plus 1. Then I'm going to take this negative root times the 5, so another minus 5 square root 4x plus 1. And then lastly, I will do this root times the root. So negative and negative makes it positive, and since it's the same base under the root sign cancels, and it's just plus 4x plus 1. Okay, so now I'm going to combine like terms. So again, this is alone here. So I have 25 plus 1 gives me 26. And then I have negative 5 minus 5, and they both have the same root, so that's negative 10 square root 4x plus 1. and then plus 4x. So now I have another radical. So I just kind of go back to step 1. I have to isolate this radical and then square again to solve. So what I'm going to do is I'm going to move everything else over to the other side. So I'll move the 4x over here with this x, and the 26 over here with the 2. Cancel, cancel. I've got 3 minus 4 is negative x. Negative 2 minus 26 is negative 28. And then I've got negative 10 square root 4x plus 1. Now, technically, I could divide by that negative 10 to completely isolate the radical. However, dividing by that 10 is not going to divide unevenly. So I'm not going to do that because when I square, it'll just distribute to the 10. However, I do want to get rid of that negative because that will help me on the left side when I'm foiling again. So that just gets rid of my negative for me. Cancel here, cancel here. So now, and it cancels here to make it positive. So now I'm going to have x plus 28 equals 10 square root of 4x plus 1. So now my radical is isolated and I can start squaring. So I'm going to square both sides again. When I distribute here, I'm going to have x squared, and then I'm going to have, since I have x plus 28 times x plus 28 here, I'm going to take in a shortcut, and I FOIL. This is going to give me plus 56x, and then 28 times 28 gives me 784. That equals, I distribute here, it's going to be 100, and this cancels the sign, so 100 times 4x plus 1. So then I'm going to distribute that 100 in, so I'm going to have x squared plus 56x plus 784 equals 100 times 4 is going to give me 400x, and then plus 100. So now I need to get this equal to 0 and solve the quadratic. So I'm going to move the 400 over. So I'm going to do 56 minus 400, and that's going to give me negative 344. And then 784 minus 100 is going to give me plus 684. Now this is where you then have the choice to solve quadratic. So you can factor, you can complete the square, you can quadratic formula, or square root if possible. This one is not. I am actually going to factor this one. With big numbers like this, always check just dividing that factor by, that 684 by 2. And when you divide that by 2, you'll find that it's 342. So I can actually break this up into x, and since it's multiplying to a positive but negative in the middle, they're both going to be negative. So it's going to be x minus 2 and x minus 342 set equal to 0. So my two x values are going to be positive 2 and positive 342. So what I need to do is I need to check and make sure that these are not extraneous. And again, you can use that calculator command. So I'll go back through here, and now I can just restore my x's too. So again, you hit the number, hit stow with the arrow, and hit x, and then hit enter. Now every time I hit x and enter, it'll give me a 2. So now when I check that, I can do the square root of 4x plus 1, arrow over to a plus sign, the square root of 3x minus 2, and get out of that, and does it give me 5? It does. So that means 2 is going to work. Okay, so 2 works. Now I'm going to check 342. So again, I'm going to store that in there. So 342 store into x. Okay, so now it's a new number. So now, technically I could just arrow up here and hit enter on that one, and it should calculate my new number there. Yeah, so now that gives me 69, which means that 342 does not work. And if I need to just double check it, 4x plus 1, because I restored it just in case, 3x minus 2. Yeah, so 69 does not work because remember, x I have stored as 342. So that means I plugged it in and it doesn't work. So that means this guy is extraneous. So when I list this here in my answers, I'm going to have x equals 342 for extraneous. So in the complex numbers, my solution is going to be just 2 because 342 is extraneous. And then for digits, my solution is 2. Okay, so when you're solving with two radicals, it's possible that they could just cancel out and you have a nice simple linear equation or quadratic equation when you square it. Or you've got this double radical in which you're going to have to FOIL with a radical. Again, not the end of the world, just a little bit more steps. You guys do have a My Math Lab to work on after this, so good luck, and I hope you have a great weekend, and I will see you next week.